Hello everyone, welcome back to Summarize and Memorize. In this video, we are going to deal with sorting algorithms, specifically selection sort. So, what is the general idea behind selection sort? Selection sort is a simple and efficient sorting algorithm that works on a single thing. It repeatedly selects the smallest element and puts it into the sorted part of the array or the list. Okay. Let's understand selection sort with a real example. So let's have few cards. So I have few playing cards with me, and we are going to treat them as our values, and then we are going to sort them in an order. Okay, so let's see. Let me just make the order like this. Okay, so we will consider ace as number one card. So what we do is, if we are starting from this index, what we'll do is we'll be keeping note of two variables. One will be a temporary variable and other will be the minimum. What we do is, first we find out the minimum number in the whole array. So let's see. So if we consider 4 as minimum and we compare it with 6, it is the minimum still. If we compare it with the ace is a 1, so it is minimum. And you can clearly see that ace is the minimum card. What we are going to do now is we are going to swap these cards. I hope since you are studying sorting algorithm, you already know how to swap. Okay, now we are on the second index, and what we do in selection sort is the index we are dealing with, before that index the array is sorted, and we are only dealing with the indices after that index. Okay, so here we have 6. We can clearly see that 4 is the minimum card here, so we are going to swap this like this. Okay, now we are on the third index and the array before that is sorted. Now you can clearly see that 5 is the minimum among these three, so we are going to swap it like this. And at the end, when we are on the fourth index, or you can see if we start from 0, then 0, 1, 2 and 3, third index, 6 is already the minimum, so we don't need to swap this, and this is already sorted. Okay, now we will have a look on the code of this program. So basically, as I told you the steps, what we are going to do is, firstly, we are going to create a function which you can clearly see here, and then we are going to define a variable minimum, or you can also skip this and you can just consider the first element as the minimum element and then find out which one is the minimum and exchange it, or you can say swap it. So we are going to use a temporary variable to swap here. I hope you already know how to swap elements as you are studying sorting algorithms now. So this is the Python code. Let's run it in the compiler. So here we have an example of selection sort with the same code. So let's run this example, and as you can clearly see, the output is getting arranged properly or getting sorted. Now, to let you see all the steps properly, I am doing some edits in the code and running it now. So if you observe the result now, you can clearly see each step of the sorting, how the first element is getting inserted at the first place, and then the second smallest element is coming on the second place, and furthermore you can clearly see all the steps here. So let's move ahead and talk about the performance of this code. So basically, the time complexity of selection sort is O of n square, and the space complexity is O of 1, since we are using only one temporary variable to do the swapping function. The advantages of selection sort is it is simple and easy to understand, and it works well for small data sets. Now, what are the disadvantages of this sorting algorithm? So basically, as we are going to study more sorting algorithms, you will see that different sorting algorithms work differently in different cases. But selection sort works similarly in all the cases, as you can see from this animation, in which there is a random array, a nearly sorted array, a reversed array, and an array with few unique elements, and you can see all of them took the same time to function. So that is one of the disadvantages, that selection sort has a time complexity of O of n square in the worst and the average case. Okay, so it doesn't work well with the large data sets. Finally, to summarize it all, selection sort is best suited for small lists or arrays where the number of elements is relatively small. It is not efficient for large or nearly sorted lists. While selection sort is not the most efficient sorting algorithms in terms of the time complexity, it has advantages of simplicity and requires minimal addition memory beyond the original list. So, thank you for watching and stay subscribed for more such content. Thank you.